Welcome to our presentation, The Future of Multicollector ICP-MS. Given the current circumstances, we are not able to meet you in person this year. So this conference is running now virtually, and therefore we decided to record this video for you. My name is Hauke Vollstedt. I'm the product manager of our group, and my colleague Grant and I are standing in front of our new instrument, the Thermo Scientific NEOMA Multicollector ICP-MS. We made this instrument for scientists like you who require high-precision isotope data in the fields of geo and cosmochemistry, geochronology, and biology, but also for scientists working in the fields of nuclear safeguards, forensics, metallomics, and provenance studies. The NEOMA Multicollector ICP-MS is a completely new instrument. It's redesigned from the ground up. It blends together and refines cutting-edge and field-proven technology. Now I'd like to hand over to my colleague Grant, who will guide you through the specific details of this new instrument.
Hello everyone, my name is Grant Craig. I'm the Application Manager for Multicollector ICP-MS here at Thermo Fisher Scientific, and I would like to join Hauke in inviting you to our event this year on the Thermo Scientific NEOMA Multicollector ICP-MS. Let us now move inside the NEOMA Multicollector ICP-MS and look at some of the exciting features that you can look forward to using in NEOMA Multicollector ICP-MS. At the heart of the NEOMA Multicollector ICP-MS is the Advanced Extended Detector Array, which has been designed around the concept of ultimate flexibility. It contains 11 Faraday cups in a mobile detector array, with 5 banks of mobile Faraday cup detectors either side of a single fixed detector, which can either be a Faraday detector or a single SEM. The mobile banks of Faraday cups in the NEOMA Multicollector ICP-MS can move further away from the center Faraday cup than ever before, giving us up to 22% dispersion. What does this mean? Well, this means we have no limitations on the applications and isotopes that we can measure. For example, we can measure all 3 isotopes of magnesium, 24 magnesium, 25 magnesium, and 26 magnesium, at the same time as the 3 isotopes of silicon, so 28, 29, and 30 silicon. Other limitations to cup movement, such as clamps for example, have also been eliminated in the NEOMA Multicollector ICP-MS design. To facilitate the use of the NEOMA Advanced Extended Detector Array, we have included in the software for the NEOMA Multicollector ICP-MS the ability to automatically align the cups to one another. To connect to our 11 Faraday cup mobile detector array, we have up to 24 customizable amplifier slots within the NEOMA Multicollector ICP-MS. Using the patented relay matrix within the NEOMA Multicollector ICP-MS, any one of the 24 customizable amplifier slots can be assigned to any one of the 11 Faraday cups, giving options for up to millions of permutations. For example, we can have a full bank 10 to the 11 ohm amplifiers, one for each of our Faraday cup detectors, and we can also have a full bank of 10 to the 13 ohm amplifiers, again one for each of our Faraday cup detectors. The all-new electronics within the NEOMA Multicollector ICP-MS have also allowed us to improve the amplifier technology incorporated within the NEOMA Multicollector ICP-MS. The NEOMA Multicollector ICP-MS is the first mass spectrometer from Thermo Fisher Scientific, which has been designed with our 10 to 13 ohm amplifier technology in mind. What this means is that we have included in the NEOMA Multicollector ICP-MS all new electronics which have greatly improved our amplifier technology across the board. For example, all of our amplifiers now have faster response and have extended dynamic range. What this extended dynamic range means is that all of our 10 to 11 ohm amplifiers can now have a range up to 100 volts, and all of our 10 to the 13 ohm amplifiers now have a range up to 1 volt, double what we had on our previous generation multicollector ICP-MS. We can also add to the NEOMA Multicollector ICP-MS a variety of multi-ion counting options, with the ability to add up to 3 full-sized SEMs and up to 8 compact discrete diodes or mobile CDDs. These multi-ion counting options within the NEOMA Multicollector ICP-MS have been greatly enhanced by the inclusion of our new extended dispersion lens optics. This allows us to use a single multi-ion counting package for more than one application. For example, a single multi-ion counting package in the NEOMA Multicollector ICP-MS can be used to measure the uranium osmium, uranium lead, and uranium thorium isotope systems. Prior to the SEM can be included a RPQ filter for a better abundance sensitivity. Let's move to the front of the NEOMA multicollector ICP-MS, where we have the Thermo Scientific ICAP-Q-NOVA Series ICP. This consists of a robust, easy-to-assemble quartz ICP torch with a field-proven argon ion source, which is compatible across the range of ICAP-Q-NOVA Series ICP, which includes the Thermo Scientific ICAP RQ, TQ, and Pro range. It consists of a balanced coil technology for ultimate plasma stability, which gives us the highest sensitivity and stability in both wet and dry plasma. Here we could have a wet plasma spray chamber, such as what we can see here, or we could have a desolvating nebulizer system to generate dry particulate from a liquid aerosol, such as the Apex Omega from ESI or the Aridus 3 from Teledyne CTAC, or we could have other options, such as a laser ablation system or a gas chromatography system here. The NEOMA multicollector ICP-MS comes with the Thermo Scientific JET interface, which has the most efficient extraction of material from the ICP-MS plasma, resulting in the NEOMA multicollector ICP-MS being the most sensitive ICP-MS available. Once the ions are extracted into the mass spectrometer through the Thermo Scientific JET interface, they are accelerated and focused towards a series of slits where we can select for resolution, with 3 resolution modes available: low, medium, and high. An optional extra high resolution mode is available in the NEOMA multicollector ICP-MS for measuring ions free of hydride-based interferences.
Here we go. Energy.
Now that we have discussed some of the important hardware features of the Thermo Scientific NEOMA multicollector ICP-MS, we need to move on to another important part of the NEOMA multicollector ICP-MS package, which is the software. Software is obviously a key component in how we as scientists interact with our instrumentation. In order to talk through the NCR software that's supplied with the NEOMA multicollector ICP-MS, I'd like to introduce my colleague Jan.
Thank you, Grant. Hello, my name is Jan Schüssler. I'm a product specialist working on the development of the new software for the NEOMA multicollector ICP-MS together with a team of software developers. The NEOMA multicollector ICP-MS comes with a Thermo Scientific Q-Tegra Intelligent Data Solution, a comprehensive software package for routine and demanding research applications. The Q-Tegra software guides the user through instrument startup, optimization, method development, data acquisition, and comprehensive data evaluation and reporting. Let's have a look at some of the features of the Q-Tegra software. Peripherals such as desolvators, autosamplers, and laser ablation systems are fully integrated and can be directly controlled through the Q-Tegra software. The collector configuration designer represents an easy-to-use interface for automated alignment of the movable collectors with a single click of the mouse. Instrument optimization by tuning has been designed with an emphasis on clear and automated workflows. The tunebooks provide a workflow to guide the user through the instrument optimization, supported by automated tuning for best performance. Sample introduction systems, such as laser ablation and gas chromatography, produce transient signals. Detector has a comprehensive set of tools for transient signal acquisition and evaluation. The entire data evaluation required for isotope ratio measurements can be realized within Detector. No third-party software is required. Method development, data acquisition, and comprehensive data evaluation and reporting is all done within the Detector labbooks. The labbooks contain a workflow structure to easily set up data acquisition and data evaluation workflows. Standard data evaluation methods can be selected, or with advanced data evaluation, Detector software provides an environment to construct your own unique data evaluation modules, which can be executed in real time.
Thank you for joining us today on our presentation. If you'd like to find out more on the new NEOMA multicollector ICP-MS, please contact your local sales representative.
Or if you have any questions for us about some of what you've seen in this presentation, please feel free to get in contact with us, either in the chat box at the event or by email. I'd also like to take this opportunity to thank you once again for joining our presentation on the Thermo Scientific NEOMA multicollector ICP-MS. And goodbye. So hello again, everyone. Welcome. Thank you for joining our presentation, as I said once again. And if you have any questions on what you've seen on the NEOMA multicollector ICP-MS, please free to put those questions in the chat, and I will get an answer to you as soon as possible. Does anyone have any questions? Okay, so is there any questions? I said, don't feel free. You can ask any question you like. We're able to answer them. Wait a few minutes. Okay, so we do have one question, which is simply asking on the size of the instrument. Well, yeah, so the size of the NEOMA multicollector ICP-MS is slightly smaller than our previous generation multicollector ICP-MS. So in terms of length, it's 2.4 meters, and in terms of depth, it's 1.69 meters. So it's still a large instrument, as you can expect, and as you could see in the video, but it is smaller than our previous generation instrument. We've also changed from having large doors on the instrument to essentially going towards the idea of having movable panels, which also removes the effective size of the instrument inside our laboratory. We've also reduced the working height over our previous generation instrument to a much more comfortable working height for most users. The weight as well has also been reduced by 500 kilograms, but that means it's still a very heavy instrument at 1.9 tons. So yeah, an improvement there, but yeah, she's still a very big instrument. So yeah, thank you for that question. Okay, we have any more questions? So we have another question here asking if we can use 10 to the 13 Ω amplifiers for laser ablation applications. And yes, we can. So we can use our 10 to the 13 amplifiers for laser ablation applications. In order to do so, as you could see somewhat in the software, we've completely overhauled the software to allow this to happen. So of course, you could see the advanced data evaluation we have for laser ablation, which makes this much easier. And even deeper than that in the software, we've fully integrated things like tau corrections and other forms of response corrections to allow 10 to the 13 amplifiers to respond at the same rate and pace as the faster 10 to the 11 and SEM detectors, allowing us to use our 10 to the 13 amplifiers easily for laser ablation without worrying about any effects of things such as spectral skew from different amplifier responses. So of course we can use 10 to 13 amplifiers for laser ablation applications. Okay, so we now have a final question here about the software and asking what peripherals does the software support. So we support most of the, or essentially most or all of modern peripherals. So in terms of what we are supporting, we're currently supporting the desolvating nebulizer systems, one of which is supplied by Electroscience ESI, and one, the Aridus 3, being supplied by Teledyne CTAC. Both of these are supported, both commercially available desolvating nebulizer systems. In terms of auto samplers, we are supporting the SC Micro DX from ESI, and we're also supporting the 112FR range, ASX 112 range from Teledyne CTAC. We're also supporting some of our own internal peripherals, such as the GC, the Trace 1310 GC for chromatography applications, and we're also going to be supporting laser ablation systems, such as the chromium-based laser ablation systems from Teledyne CTAC, and the ESL NWR series are also supported by plugins. So we're supporting a wide range of peripherals across the instrument base. Just a question about sensitivity, asking what the sensitivity is. Well, the sensitivity, as was stated in the video, maybe came a little bit late. The video, what we could see was that the sensitivity of the instrument is the highest sensitivity which is available on the market for an ICP-MS. This was also true of our previous generation Neptune Series multicollector ICP-MS. So with the jet interface, particularly in dry plasma, we can achieve the highest sensitivities available. So for uranium, for example, we specify in dry plasma a sensitivity of 1,200 volts per ppm. And again, this is mirrored across much of the periodic table. And I said we stand by the statement of having one of the most sensitive mass spectrometers available. So we have a question here about advanced data evaluation and will we provide any pre-installed scripts for advanced data evaluation. So data evaluation in the Neoma multicollector ICP-MS comes in two forms. We have the standard data evaluation, which will be very familiar to anyone used to the Neptune series multicollector ICP-MS, but in a much more streamlined, much more clear manner, but fundamentally laying out the data evaluation in a very similar method to that technique. What we have essentially done with Neoma is we have a standard evaluation which very much follows that model, but then you have the advanced data evaluation. Now, whilst we won't be providing pre-installed scripts for the advanced data evaluation, it's possible to create a method in the standard evaluation and then open it into the advanced data evaluation, sort of that acting as a pre-installed script, so creating most of the code that you would require that you can then annotate to exactly what you would require. And whilst we will not be providing any pre-installed scripts, unfortunately, with Neoma, there is obviously the function in the software to import and export these scripts for advanced data evaluation. So anyone in the community who creates a advanced data evaluation script for the Neoma multicollector ICP-MS can export that and can share it around the community with anyone else who also happens to have a Neoma multicollector ICP-MS instrument, allowing the community to share data evaluation methods easily. Okay, so if we have no more questions, if you're not shy, you can ask any more, but if no one else has any more questions, I'll say we'll give it another 1 or 2 minutes, and then do you have any questions? No? Yeah. Okay, yeah, so it looks like we have no more questions. So I would like to thank you all who are still here for joining our presentation once again on the Neoma multicollector ICP-MS from Thermo Fisher Scientific. Again, if you do have any questions and are just shy to answer them here, of course, you can feel free to email either myself or someone else from Thermo Fisher Scientific, your local sales representative for this product, and we will get in touch as soon as possible with any questions you may have, and hopefully we can provide the answers for you. So again, thank you for your attention, and goodbye. Thanks very much for being here.